In this video, we're going to talk about confidence intervals for means. So we're going to start by introducing what a confidence interval is. So for example, if we have a sample of 40 randomly selected women and we record their pulse rates, we can calculate the mean pulse rate of our sample. Maybe it's 76.3 beats per minute. And we can assume that sigma, which is the standard deviation for the population, is known to be 12.5 beats per minute. And we'll talk about that more a little bit later. But our sample mean of 76.3 is what we call our best guess. It's also called the point estimate. Basically what we're saying is I can calculate the mean of my sample, and I want to be able to say that this tells me that if I took the mean of the entire population of women, it's probably about 76.3. If we take a different sample of a different group of 40 women, we would not expect to get the exact same 76.3 value for the mean. Now, it's probably going to be somewhat close to that, but it's probably not going to be exactly the same. There's variation from sample to sample, which we learned before is called sampling error. So we're going to get slightly different values depending on just who happens to be in our sample. So one thing that we can do instead of looking at the point estimate is report a range of values that we think that the mean falls between. And that allows us to be a little bit more, give a little bit more information about our calculation. So instead of just saying we think the mean is about this number, we can say that the mean is probably between these two numbers. And that's what's called a confidence interval. It's an interval because it's two numbers that we think the mean falls between. Now, when we have a confidence interval, we also have a confidence level for that interval. And the confidence levels that we're going to be using in this class, the ones that we can use in Minitab, are 90%, 95%, and 99%. As the confidence level decreases, the interval gets smaller or narrower. So we exchange higher confidence in our interval, we exchange that for a wider interval. So if we have higher confidence, then that makes our interval so that the numbers are further apart, and we know that the mean is somewhere between those two numbers. So basically it makes it so that there's more possible values that the actual mean could be. So for example, we're going to do this on Minitab. We can use Minitab to find a 95% confidence interval estimate for the mean pulse rate for women. And we would get this, 72.43 to 80.17. And you'll see this written in parentheses in Minitab. That means between those two numbers. So the way that we interpret this for 95% confidence is that if we were to select many different samples of 40 women from the population and construct a confidence interval, 95% of the time our interval will contain the actual mean. And so looking at this picture, this shows it pretty well. This is for a proportion instead of a mean, but it works for means too. If the green line is the actual mean for the population, and each of these is our interval, we can see that the interval captures the mean out of 20 times, it captures it 19 times. This one right here is where it does not capture the mean. And so that's in that 5% where we just happened to get a sample that was not very representative of the population. But 95% of the time, we can be confident that we have the true mean in our interval. Now, when we're using Minitab, this is very important, the standard deviation. We need to pay attention to whether it's known or whether we're using a standard deviation estimated from a sample, because we do different calculations that give us different values depending on that. So if standard deviation is known, then the calculation is based on the normal distribution, and in Minitab this is called Z. And I'm going to show you in a different video how to do this on Minitab. Problem will refer to the standard deviation as population standard deviation, or sigma. If the standard deviation is not known, then it's based on a different distribution called the T distribution. And so in Minitab you're going to be looking for T. And this situation, the problem would refer to the standard deviation as a sample standard deviation, or S. So the problems are worded differently, and you really have to pay attention to that to figure out whether you're going to be selecting Z or T. So for these examples, all we're going to be doing is determining whether we will select Z or T in Minitab. So question 1 says, in the study of the length of time that students are required to earn bachelor's degrees, 83 students were randomly selected, and they were found to have a mean of 4.8 years with S equals 2.1 years. Now, they're giving us S. When we see the letter S for standard deviation, that refers to a sample. And when it's a sample, that means we're using T. Number 2 says, in a recent study of 68 eighth graders, the mean number of hours per week that they watched television was 19.1 with a population standard deviation of 3.8. So we have population standard deviation, population means we're using Z. And it'll make a little more sense what we do with the actual T and Z when you watch the video of how we're doing this on Minitab. Question 3 says, in a random sample of 42 people, the mean body mass index was 27.8 and the standard deviation was 6.16. Find the 99% confidence interval for the population mean. Now this one is a little bit trickier because it just says the standard deviation. It doesn't say sample or population in front of it. However, if we go back here, it's in a random sample of 42 people. The mean was 27.8. If you take that part out of the sentence, it's clear that in a random sample of 42 people, the standard deviation was 6.16. That's a sample. And so when we have a sample, we are using T.